we defined a solution before. We talked about that solutions were mixtures where basically we have one substance that's dispersed through another, and the substance that is dispersed basically has particle sizes that are less than a nanometer, and as a result, basically, that solution in this case is homogeneous, that is, that the particles are uniform throughout it. And we talked about some other things that deal with that. But right now, we need to do a little bit of definition about the parts of a solution. A solution, what we're talking about here, is made up of a solute dissolved into a solvent. And so the solute, the first part we're sort of dealing with here, is the material which is dissolved. So if we were talking about salt water, the solute in salt water would be salt, because it is the material which is dissolved, and salt is dissolved in salt water. It's the one that actually is dispersed throughout the other one. The solvent is the dissolving material. That is, in salt water, it would be the water. So it would be the material which the solute is dispersed into. So that's the solvent here. The solution, on the other hand, is the combination of the two. So it's the combination of the solute and the solvent. So in salt water, the solution is the salt water. So in a sense, if we know the mass of the solute and we know the mass of the solvent, if we want to find the mass of the solution, we'd simply add these two guys up, and that would equal our mass of our solution over here. And so those are your three parts here. Solute, solvent, solution. And if we want to figure out the concentration of the solution, and we say concentration, basically what we're dealing with is this issue here. We can have a solution which has different amounts of solute with respect to the solvents, different proportions there. You can imagine, if we're talking about salt water, is that we could have, a gallon of water and we could put 1 grain of salt in it. Do we have a saltwater solution in that case? Yes, we do. But that's a very different saltwater solution to one in which you were to, say, dip a gallon of ocean water out. Which has much more salt, much more solute in this case, mixed into the solvent than does the one where you simply have a grain of salt in the whole solution. And so we need a way of basically being able to describe how much solute there is in a solution proportionate to the whole solution as a whole. Sort of in this case, how salty the water is, or in the case of something like an acid, what the concentration of that acid is, how strong it is. And so if we want to talk about the concentration of a solution, so this is what we're dealing with here. The concentration of a solution is described always in terms of the amount of solute per either solution or solvent. So it'll either be amount of solute per solution or it'll be amount of solute per solvent. But when we say amount, that's a pretty general term. Amount could be volume, it could be mass, could be number of moles, number of atoms. And so as a result, there really isn't one good way of measuring concentration. There are actually probably a good 24 or so that are used in various ways. We are going to focus in this class on 3 different ways of measuring concentration. And the first one is the one that's actually probably most commonly used in sort of everyday life. And that is called percent by mass. And so let's take a look at this. Percent by mass, or sometimes called the mass percentage, is one way of measuring concentration. And the equation is basically this. That percent by mass is equal to the number of grams of solute divided by the number of grams of solution, and then times 100. We have that times 100 out there is basically because this is a percent. And so we need to basically multiply by 100 to get into a percent form. So let's take a look at an example here. We have 14.5 grams of KCl was dissolved. Let's see, get rid of that was. That's gone now. 14.5 grams KCl is dissolved in water to produce a 210 gram KCl solution. What is the percent by mass? So we know this. We know that percent by mass is going to be equal to the number of grams of solute. And so in this case, what's our solute? Remember that the solute is the material which is dissolved, not the one that does the dissolving, the one that is dissolved. In that case, it's going to be the KCl, the potassium chloride. And so that means, how much do I have of that? Well, we're looking for, as it says, grams of solute. And so I have 14.5 grams of KCl over the number of grams of solution. My solution here is water, because it says dissolved in water. And so actually, I'm not even paying attention here, am I? So gram solution, not the grams of solvent. The water is the solvent, not the solution. And so I'm looking for the number of grams of solution here. Number of grams of solution. And so it tells me the grams of solution, KCl solution right here, is 210 grams. And so we have 210 grams of solution here, and then I've got to multiply that by 100 to get it into the right form here. Doing so with my grams of solute divided by grams of solution, that if you take out your calculators, then you can sort of set it up and you say 14.5 divided by 210, and then you have to multiply that times 100 to get into percent, and so I get 6.90 is what I get out of this. So 6.90%. In this case, look at significant figures. I start off with 14.5 that has 3 sig figs. 210 has 2. So my answer should have 2. So my final answer is this is a 6.9% KCl solution, potassium chloride solution. As I said, this method is the one that is probably the most commonly used in everyday sort of life. You will sometimes see this when someone talks about something being, say, a 10% saline solution. Basically, what they're just saying here is that's the percent by mass. That this is 10% by mass saline or salt solution. And so this is how you'd work out percent by mass problem. So the most common method for measuring solution concentration chemistry is molarity. The symbol for molarity is capital M. And it is important that this is a capital M, as we'll find out in a second. There's something else that's lowercase m. Typically is if you're describing something with respect to molarity, you'd say that if you have like your molarity is 7, you'd say it's a 7 molar solution, and you'd write it out sort of like this. You'd say 7 capital M. That's how you show 7 molar solution. Has a molarity of 7. And so that's sort of just formatting on that. The definition of molarity is equal to the number of the moles of solute divided by liters of solution. And the reason why molarity is so useful is that if you are reacting something with a solution, or you're reacting two solutions together, whenever you're doing that, you're going to want to do stoichiometry, for one thing. And since you're doing stoichiometry, you always have to go to moles first. And well, if you have, to start with, moles of solute, then the solute's what really does the reacting. You don't have to do another conversion. If we had something in terms of gram solute, we'd have to, go from our concentration to find the number of grams, and we had to convert from grams to moles. Using molarity, once you found basically what your molarity is, it's relatively easy to go ahead and figure out how many moles you've got. It's already in moles. The second reason why that molarity is so commonly used is that typically when you're measuring liquids, you don't measure them by mass. And so if I have some solution, if I want to measure it out, typically I'm going to pour it into a graduated cylinder or some other volume measuring device, and I'm going to measure it in liters. And so by using molarity, if you're trying to figure out how many moles you have, all you really have to do is just measure out your amount of volume in liters, and then it's pretty easy just to plug it into this equation here, and then that'll tell you what the molarity is. Or if you know the molarity, and you know how many liters you have, it's very easy to figure out how many moles you have. And so this is basically the reason why molarity is such a nice unit of concentration to use. So let's start off by seeing how this works here. So we have an example. Half a mole of sodium chloride is dissolved to produce 250 milliliters of solution. What is the molarity? So in this case right here, we're looking for molarity. Molarity is equal to moles of solute. And so in this case, what's the solute here? It's sodium chloride dissolved into presumably water in this case. And so sodium chloride is going to be basically what our solute is. And how much we have? We have half a mole. So we have 0.5 moles of that guy right there, divided by the number of liters of solution. We're told we have 250 milliliters. 250 milliliters, remember milli is thousandth. We move the decimal place over 3 spots, and so this is going to be 0.250 milliliter, or liters, not milliliters, liters right there. Okay, and then once we've done that, that should tell us the molarity. And so we take the calculator, 0.5 divided by 0.25, and in this case you get 2, which should be fairly obvious there. And so in this case, this is a 2 molar solution. Significant figures, half a mole has infinite significant figures, 250 milliliters has 2. Our answer should have 2, so actually this is one of these rare cases where we actually have to increase the number of decimals we have on here. And so our final answer is this is a 2 molar sodium chloride solution. And so that's how you basically work out molarity. You may have noticed that unfortunately, these last two things have some very, very similar names, molarity and molality. He's got to be a little careful. They just happen to have similar names. There actually is a third form of concentration called molality, which we're not going to talk about. So you have, molarity, molality, and molality. But molality is the one we're dealing with here. This is often confused with molarity because it sounds similar. Molality, which notice the symbol for that, lowercase m. That's why we got to be careful of our capitals and lowercases. Capital M is molarity, lowercase is molality. So molality is another measurement of concentration. The definition is this: molality is equal to the number of moles of solute over kilograms of solvent. Note that this one is a little bit different than our previous two, in that previously we always had some amount of solute divided by some amount of solution. For percent by mass, it was grams of solution. For molarity, it was liters solution. But this time we have kilograms of solvent. So molality is used a lot of cases whenever you are either you know how much water you're adding, you really don't care about how much total solution you get, all you know is what you're adding there. It's also oftentimes used in reaction kinematics, which we'll talk about later on in the year, and it's used in, we'll use later in this unit here, in cases where you're trying to figure out how solutions change what the boiling and freezing points are of liquids. And so this is molality. So we'll work out an example here. 300 grams of sulfuric acid, H2SO4, is added to 300 grams of water. What is the molality? So in this case right here, we know molality is equal to mole solute. So our solute here is the sulfuric acid, H2SO4. We need moles of that though. We're given grams, 300 grams. We're going to have to convert that. And so what you want to do first is set up our table. So we have 300 grams of H2SO4. And we want to go ahead and try converting that over. We want to get rid of grams. We want to go to moles of this right here. And so once again, break out your periodic table. We have, in this case, 2 times hydrogen, which is 1.01, plus 1 sulfur. Looking at the periodic table, we see the sulfur is 32.07, so plus 32.07, plus SO4, so we have 4 oxygens, so plus 4 times 16. And so in this case, I get 98.09, and so 98.09 grams in 1 mole. And so doing this, we'd say 300, which is the number of grams we start with, divided by 98.09. And so I get 3.058 moles. So I know I have 3.058 moles of H2SO4. No rounding yet because we're not to our final answer. We want to find our molality. Well, molality, we said, is equal to the number of moles of solute, which we just found, 3.058 moles, divided by the number of kilograms of solvent. Solvent would be water in this case. How many kilograms do we have? Don't know, but we have 300 grams. Easy to convert. Remember, once again, is their kilo to grams is a conversion above 1,000, and so 300 grams would be 0.3 kilograms. So we have 0.3 kilograms here. So to find the molality, we take our 3.058 divided by 0.3, and I get 10.195. Significant figures. In this case right here is I've got 300 of each one, so that has 1 sig fig, that has 1 sig fig, and so our final answer is going to have 1 sig fig, and so in this case right here, our final answer is just 10. So we have a 10 molal solution. And so this is where I have to be a little bit careful here. Once again, we're talking about molarity. It's called a 10 mole. It would be called a molar solution. With molality, it's called a molal solution. But in this case, I have a 10 molal H2SO4 solution. Would be my final answer. So that's how you do a basic molality problem.